We're here on 9.14, and so 123 and 124 are coming up, so I want to demonstrate them, and then I want to demonstrate some Ollie debug stuff, which isn't due for a few weeks, but is more directly related to what the lecture was about. So let's start with 123 and 124, importing DLLs here. All right, and like I say, whenever the projects say you need the Flare VM, just use our Windows 10 VM. I haven't changed the instructions here, but the modern Flare VM, we don't need it. So I'm going to go to my Windows 10 machine, and I'm going to move these instructions to the side so I can see them. All right, so we need to download this file called hello4. So the best thing to do is to use Internet Explorer to download files. It's more likely not to complain about these files. Paste and go. Good, and it's found it, hello4. I will save it. The publisher couldn't be verified. That's fine. View downloads. There is something called hello4, and it complains, but it doesn't refuse to download it. So in this downloads folder, I have this thing called hello4. Okay, now I can run it. And since this is Windows 10, I can go here. I can open a PowerShell window right in that folder, which is okay. You can use PowerShell just like it was a CMD window, and it'll be all right. So I can do a dir, and I'll see there is a thing called hello4, and I can run it with the ./hello4, and it says, hello, I use DLLs. Okay, so nothing very exciting. All right, so we can examine it in PE view, and I'm looking at the addresses. I'm just scrolling ahead to see what the point here is. Yeah, it's going to be set DLL characteristics. Okay, so we're going to play some games with this program. So let's look at it in PE view. All right, and it's downloads hello4. Okay, and so if you go to the import address table, which is in section iData here, here's the import address table. You can see it uses a lot of functions. And these are all in kernel 32, but many API calls, all in kernel 32, close handle and get file type and a lot of things. So those are all from the single library, kernel 32. All right, now the last function here is raise exception. It's got a P file address of 5954C and a data of 5D9DA. And so if you look in the iData section, you'll see a raw hexadecimal dump. Now this address here was 5954C. If you go here, you see the raw data 5954C is here. This is 40. This is for 89ABC. Here's 595C over here where my pointer is. So that has DA D905, which is the number 05D9DA in little endian order, where the bytes are reversed. So that's what we saw in the other diagram. And that is the address of a Windows function call, a Windows API call, stored in here so it can find it. So that's the game. All right, so if we look at the import hints and DLL names section, which is here, then we can find raise exception, 59DDA, and so 59DDA is here, and you can see that's where it's starting. Here's raise exception, starting right there, 4 bytes from the end. So that's the name of it. Here's where the name is called. That's the name of the function, and the other part is where the pointer to the function was, so it could find it. So that's how the import tables work. All right. Anyway, let's play with the image base address. That's a simpler thing. All this stuff about how it finds the function calls is useful when you want to fix a corrupted import header, which you do in some of the extra credit portions of these projects. So the image optional header is here, and this has the base of code and base of data, and the image base. And the image base for an exe is almost always 400,000. I don't know why, but Windows programs always think they're going to run at 400,000. So that's the natural address where it wants to run. Now, if we actually run this program in Ollie, we'll see where it really loads. So here's Ollie with something else. I'm just going to do File Open, Hello4. Okay, so now I got Hello4 running, loaded, but not running, and now I can view the memory map. And here's Hello4, and you can see it really loaded at 280,000, not 400,000. So it loaded at a random address. That's because of address space layout randomization. Now we could turn off address space layout randomization for the entire operating system in the registry, but that's overkill. What we want to do is modify this program so it will not perform that operation anymore. And we can do that with setDill characteristics from Didier Stevens, who is a fantastic guy that develops a lot of useful software. So I'll go here and download that, which is get rid of this stuff. Okay, and now paste and go. Okay, here's his blog about setDill characteristics. And there's the download. Save that. Okay, open folder. It's a zip file, so I need to extract all. Extract. Okay, and there it is. Place the setDill characteristics.exe is the only program we need. That needs to be in the same folder to make this easy. So I'm going to move that out of this folder and put it in the downloads folder where my hello is. And now, in my command prompt, I should have them both in the same place. If I do a dir, I've got hello4, and I've got setDill characteristics here. So I can now use this program to modify the characteristics. And so you see I can set and clear certain flags here in the program, and dynamic base is the one that lets address space layout randomization happen. So all I need to do is use the -D to get hello4 to stop using ASLR. So I can do this hello4 there. That will change that flag. Now it can't open the file because it's still open in Ollie debug. So I got to close Ollie debug because it can't modify it while it's running. So still wasn't able to open it because I might still be running it somewhere. And PEView might be locking it too. All right, let's try it now. Yep, now it worked. So now it changed that value dynamic base. So now this program should no longer randomize in memory. So if I run it in Ollie now, okay, and I do file, and it's right here, hello4. I load it and then view memory. Now it loads at 400,000, its preferred location. It no longer participates in address space layout randomization. So this will save you from getting some headaches when analyzing it. You won't have to add some thousands to every address as you compare the running version to the version you see in a program like PEView. So that's kind of fun. And so there's some flags to find here, and there's some programs that are broken that you have to fix. Or you find some things in here. Yeah, all right. So that's 123. And I had to keep twitching WinDef off and on. No, it was something else. All right, anyway. So I'll turn this off. Windows Defender, yes.